We are good to go. Folks, it's so cool to see you all chatting because there's such a lot to discuss. We'll have two final sessions and they are really relevant for everyone who want to make token engineering a practice in a crypto startup. And I invited two guests. I'm very happy that Lukasz Szymanski and Tom Mellan are here. Thanks for coming. Have a seat. And we'll discuss establishing token engineering at your startup. I'm glad that you are here because you are both token engineers. Lukasz, you founded your own company. It's a service firm for token engineering services. And Tom, you're working at Crypto Econ Lab as a research scientist. So meaning we can share different perspectives, probably. And I guess we should start with a brief introduction, your background. What brought you actually to token engineering?
Yeah, hello everyone. So my name is Lukasz Szymanski. I'm running Tokenomia Pro, which is a token engineering agency, let's call it like that. We are focusing on modeling and simulating different token-based system, crypto economics. And my background before running this company, my background is software engineering and then managing software engineering teams. So before I started Tokenomia Pro, I was director of engineering in Olix Group, where I was running the teams of hundreds of software engineers in Europe. I was also working a little bit at Spotify. So I have this experience with startups and also big companies that are around not only software, but also data science and all of these different processes, which are important in token engineering context. And what brought me to the space? The possibility to basically create novel economies and deploy them at scale and try them out, which is not possible at the, let's say, in real world.
Nice, thanks. Tom, how did you?
Sure. As Angela said, my name is Tom Mellan. I work in Crypto Econ Lab, and which is part of Protocol Labs. So how did I get here? I had kind of a circuitous route, really. I originally trained in computational physics and did my PhD and worked for some years in that field, and then gradually moved more into a more data science, machine learning / kind of large-scale incentives, but not in the crypto blockchain world, but more in infectious disease epidemiology. And worked in that for a few years, and then eventually ended up switching to blockchain. And why? Really just because there's like a huge sense of optimism and possibility to combine effectively a new way of computing with incentives, and yeah, that's a very powerful idea. So I've been working in this field for a couple of years now. I run a token engineering / crypto economics mechanism design, protocol design, call it what you want, team in Crypto Econ Lab. We primarily focus on the Filecoin core protocol, but we also do work outside of that, advisory and consulting too.
Nice. Maybe you can both give us a picture of how a typical project looks like in terms of the steps, the duration, a typical outcome, a typical starting point.
Yeah, sure. So for me, and it might be a bit different for Lukasz, it really depends what the type of project is, whether it's an internal Filecoin project or it's an external advisory project. If it's an external advisory one, the kind of steps are there's some like sourcing and meeting the clients. Like how do you do that? I mean, you talk to people, places like this. And then after that, there's a process of onboarding clients. So there's part of this is due diligence from our perspective to see are we aligned in terms of values and where we want the projects to go. Scoping out the project, talking back and forth with the clients. There's a kind of continuous process of iteration and then coming up with a pricing proposal. And if everybody's finally happy with the milestones and timelines, then you move forward with that. And a project could be scoped anything from like a month up to 6 months, or you could have a more kind of permanent retainer structure, or you're working kind of long term with a project like Filecoin's core protocol, which is what I focus most of my work on. And like, how do projects arise, crypto-economic projects arise, for example, in Filecoin core protocol? Many ways, but I mean, you're kind of really embedded in the ecosystem. So, I mean, you have this process of continuously auditing the protocol to see, hey, what could be improved? Are there any, potential approaching icebergs? Any potential bugs that we got to think of? But you're also really kind of embedded within the ecosystem and the community. So ideas will bubble up and come to you. For example, in Filecoin, the storage providers might say, hey, like, we really want to onboard more storage, but this is our bottleneck. Is there some incentive design structure that can help us alleviate that bottleneck? And so that's like a kind of typical way that a project comes up in Filecoin.
Okay, makes sense.
The question about the process can sound like simple, but actually it's really challenging to come up with the proper process, especially when we are doing simulations, because I'm always saying that you can model and simulate basically everything that you want, but then you have two constraints, main constraints, which is time and budget, right? So of course that I'm talking from this perspective of the person who is working with external clients. Of course that client would like to always have an answers to all of the questions, but then we don't have probably enough time and enough budget to do all of that. That's why our process consists like kind of the foundational process, which takes around 3 to 4 months, I would say, depending on how the big project is that the first phase is kind of phase of system requirements, which we are using in order to not only get the requirements from the client, because in most of the cases, clients don't really know what they want, and we need to help them to figure this out. So you can treat it as a more like discovery phase / system requirements phase. But the most important thing is that at the end of the day, the deliverable is what we are calling model design document, which is this first milestone where we are saying, okay, so this is how we end up this first step, and this deliverable is our input for the next step, which is creating a model. In our case, it's CAD right now, but we were chatting before about the bottleneck of CAD not being ready for high performance running as we need it right now, so we are hacking it a little bit. But anyway, then the second step is modeling, where we are just basically providing model and verifying does it work with the assumptions. And the third stage is simulations. We are running simulations that their main goal is to answer the questions that were in the model design document at the first place. So this is the foundation. And additional comment is that you always need to be ready for the fact that you will switch between these phases. So you always need to assume that you can go from the third step back to the second one, or even to the first one. And then, of course, that client project wants to take these simulations further, so answer more of what-if questions. And then what we are doing, we are just basically estimating it again. We already have all of the tools that we can run on top of it. So we are estimating it, client is accepting this stuff, and we are running it again, just briefly.
Right. I wonder, what are the typical challenges in scoping a project? You've mentioned sometimes you have to help the projects to really find out what they want or need. What are the typical challenges in this setting, defining a scope?
To define the scope? So it kind of depends from what perspective you're coming towards in terms of scope. So I mean, if you come from the perspective of like running a team of several engineers and research scientists, I mean, I tend to bias more towards or like hiring people who have a lot of potential, who tend to be on the younger side. But then like something you often see is they like greatly underestimate the scope of a project and how quickly it is to do. So that's like one thing to watch out for in terms of scope.
So be careful for at your own team to not.
Yeah, I mean, there's like different perspectives of like thinking about like how do you run token engineering in your startup. This is like more from the perspective of like running the team, rather than from the perspective of hiring the team, which is another perspective. Yeah.
I've had this own experience. You always feel too slow. You mentioned CatCat, and for those of you who don't know, CatCat is an open source tool. It's actually a Python library, open sourced in the token engineering community to run simulations. Now, it's one of the tools, and one observation during ESTC for myself was that more and more teams start to build and come up with tools that they build internally for their teams or that they provide for clients. What are the most interesting developments here?
Yeah, so that's kind of interesting. That's like what Lukasz and I were just speaking about before we came on. So we kind of have slightly different approaches. The approach that we've taken for at least through the Filecoin work, and partially this is because this is like a long-term engagement, so you can spend a really long time building custom software, really building everything from the scratch, ground up. So I mean, the kind of typical stack we use is the standard Python data science stack, but then we build up our simulations on top of that. So we generally build our simulations using JAX, which is the accelerated linear algebra library for Python. And this is really good. So this has allowed us to build models that are very easily vectorizable, parallelizable, but also differentiable. So this just like opens up a whole new world of being able to do experiments. So the way we kind of approach it is we have let's take, for example, the supply simulations. We have a kind of basic skeleton model for supply simulations, and we can run this a few different ways. You can kind of take a signal processing approach, where you have some signal driving it, and then this feeds into the rest of the model, and you get some output. Or you can take an agent-based approach, where you have some subpopulations of agents, and they're making some kind of rational decisions, and this is what's driving the network. Or you can take another kind of approach, which is like the one I alluded to, which is where you have some, say, unknown parameters or some like structure in the model that you want to test, and then you can optimize this, or you can like take like an MCMC approach and even like infer a distribution for a parameter. So that's kind of how we tackle the simulation side. Yeah.
Actually, already pretty broad variety.
Yeah. We got like a good arsenal of weapons, I think, to tackle the economy. But how is that different or similar to you?
Yeah. So besides like standard Python data science stack and this needs running something more sophisticated than like a Jupyter notebook. Because also, like most of the materials that you can see available on the internet or tutorials whatsoever are on top of Jupyter notebooks, right? Which, I mean, it's fine, of course, it's the industry standard in whatever industry, like in general data science standard. But then when you have this need of really running a far much bigger model or more like computation-heavy simulations, then, like for example, in our case, what we are doing, we are using Jupyter notebooks maybe just only at the beginning just to check something out, like initial verification. But then what we are doing, we are using our own, let's say, technical infrastructure that we have, where we are running our CatCat simulation on top of the cloud. Where we were discussing the performance issues with that even yesterday night I was doing the performance test and comparison about running CatCat with different instance types and so on and so on. So there is like, it is enough to some degree, but once you really want to put it at scale and make sure that your simulations are running fast, like you have different ways. So either you are building your own tool, which is basically from the get-go designed to be as parallel and as, let's say, computation performant as possible. Or, but then again, it's the case where you have just, you are working inside some client in a long term. But then for a company like ours, we are thinking more about contributing to CatCat, where we will be able, for example, to contribute in a way where it will be able to address our needs that are not addressed right now. So yeah, in terms of stack and tooling, this is what we do. And yeah, mainly also I would say in terms of tooling, something that Trent said today, all of this, I do believe that there will be more and more tooling around the verification. And that's why also we are building our own standardized tooling for verification on top of the CAD, and also models on top of the CAD, which I think at some point in the industry we will finally reach some probably agreement how to do that, and then we can just easily exchange between each other with the models that we created.
Which is currently not possible, right?
I mean,
What's the landscape?
It's possible, but it's not happening, basically. There is no... I even seen that recently CAD announced some changes, I think some major changes in the framework itself, which is not helping. Because again, for me, it's if you are like really looking like down to earth, for me, it's again the cost just basically of time of people that needed to align to that, while we already prepare all of the stuff on top of the actual version. And then it's not also helping in developing the standardized way of how to approach CAD simulations, because again there is some major change that can break things that were in the past. So it's possible, but not happening. I do believe that this event is a great start to actually start to talk about it. Maybe, who knows, in future you will organize the conference only about this stuff, where we can deep dive into more like technical topics and bring some consensus to the space.
What's your point of view here?
Yeah, that would be really cool. I mean, I'm just like drawing in on the last point you made, where it would be good also like dive more deeply into like the differences in the technical approaches that we use. I mean, I was kind of curious, like, do you find this to be a big limitation or like a bottleneck for your work, the fact that it's quite computationally intensive?
When it comes to work with clients, no, not really. I mean, we can afford ourselves to run a simulation that can take up to 1 hour. A simulation that consists of hundreds of Monte Carlo runs, hundreds of parameters and this kind of stuff, which we already optimized, because normally it took like, if you would like to run such simulation on your local machine, then like you can count something around 1 day, probably up to 1 day. If you will put this in a Docker, then forget about it, because probably your memory will be not enough. At least this is what and this will kill the process, and this will be after the simulation. So for the clients, it's not a big problem if you are running it in an optimized way, especially if you have infrastructure for that, which is an important point from like people considering perspective of, should I build team internally or should I hire external team? The one thing is, first of all, it's a team, so it's not one person. So the one thing is a team that conceptually can like do this stuff, can have this knowledge, but then you need to provide infrastructure so they can basically operate around it, which then performance is also the case. But for our other needs, where we are running basically tokenomics audits at scale, and we are simulating like hundreds of projects, and you want to iterate on this model, and you want to have results as soon as possible, then it's an issue.
Yeah. I mean, it's really helpful being able to iterate on the scale in terms of like which we think and like work. If you can run models on the scale of like 15 minutes and keep iterating on ideas, that's really powerful. Like before, whenever I worked in computational physics, we'd use high performance computing, thousands of cores, and run a job for a week, and it's just so painful. We don't want to be going down that scenario, although I suspect there's always like something in us that's drawn towards that. It's like the kind of principle, or like whatever it is, the first law of high performance computing, that whatever computing resources you have, you like fill to expand it. So sure, we'll like make our models like really efficient and parallelized, but then we just want to test more parameters and more questions, right? Yeah.
Rohan, go.
No, I didn't find time yet. But if there are some like better performance solutions, then I would be happy to check this out. My approach was like, okay, CAD. I think that the version, it's 0.4 something now, which is, it didn't yet establish the, let's say, first version where everyone can say, okay, it basically works. So then I was like, I'm not going to jump into another tool that is kind of the fork of it, because then like the development probably is even more in alpha stage. So, for me, I can't afford this kind of, let's say, bugs that are coming from the tools and not from the human mistakes.
We mentioned teams, so not only tools are relevant, also the people who are part of a token engineering team. So we got to that. It's not only a single person. Let's jump on it. Would you recommend any crypto project to hire a token engineering team? Lukasz?
To build internally from scratch or hire external. Yeah, okay, of course I'm biased. We also were talking about it. But to be like totally objective, I do believe that, okay, if there is like, for example, a project like Filecoin, which I don't remember, but I assume that go research driven, then probably like the only way to go is to build the team from scratch, because you already have people that are knowledgeable about the space. But for, let's say, most of the cases, I would say this is an exception to the rule, where the rule for me is that most of the places is occupied by, startups or mid-sized projects where they still need to validate their own proposition, and they need to find their market fit, and they need to do it fast. So then the most let's say objective or standardized way how we are doing with the clients, I think it's even similar in the software engineering world, is we are starting the whole thing in the client situation, which is we are bootstrapping everything around token engineering, so teams, tooling, processes, and so on. And then after we had the first results, we are starting to kind of handing off the whole stuff after the project verified their market fit and they have, for example, money to expand more. So of course they will think about, hey, let's build team internally, and Lukasz help us to transfer the knowledge and to make sure that this will work inside. So this is, I think, the best model for startups.
Maybe you can share, Tom, how this internal team, we mentioned it a couple of times, Crypto Econ Lab has been grown in-house for Filecoin at Protocol Labs. How was this journey?
Yeah, for sure. So in Crypto Econ Lab at the moment, there are 9 research scientists, and we built that up over the past 2 years. And if you're going to have a full-time in-house team of research scientists and engineers, yeah, for sure you need like more funding for that to sustain it long term. It's also non-trivial to set up, in the sense that hiring people is not easy. If you get a false positive, that's a big cost, and it is difficult to hire good people. I mean, there's a lot of talent out there, but not in the same way as in other fields where people have been doing it for 40 years. So there's like quite high variance. So going through that whole process of hiring engineers and research scientists the same way as you would do in any kind of tech business is like a slow process. There's like many stages, really. So that's one thing. But, I mean, we've got ourselves into a great position now. We've got a very strong team with a whole range of different skills. So what we try to do is like set it up such that there's a real sense of kind of complementarity. Like some people have a background in machine learning and control theory. I mean, if I just like literally go through the people in the team, and this guy has he's an excellent research software engineer as well. We got other people who are more into game theory and governance, which is like a super important part. It's like fine to say, okay, here's your tokenomic design, here's the research, this is what you should do. But if it's for an established ecosystem, then you need to be able to pass this through governance somehow. So that's really important. And then we've got other people who work more on the theoretical side, so more pen and paper analysis of incentives. We got some PhD stats people, that's very useful, and more machine learning. And so like some of the people we've drawn from come from academia, but some are much younger, like 22, 23, and they're just like so smart and excellent domain knowledge and really on an upward trajectory. So like having a whole range of skills and abilities, that's very important. But it's also not sufficient, I would say, just to draw on people who have these very strong technical skills. You also need people who have a bit more of a business sense and can run in a startup culture and like not get too deep into the weeds, but step back and see the bigger picture and really keep things moving forward. That's really important. Yeah.
And how relevant are, I think Crypto Econ Lab since minimum a year invests in sharing your work, you're publishing articles about your work, you're even open sourcing models. You're visible with your work. How relevant is it in terms of finding talents?
Yeah, that's true. I was kind of pleased to see some Crypto Econ Lab work in the previous slide. We do try to do everything open source, so we open source our models generally, and we open source all of our research in general. And this has been good. I mean, this is how we've attracted some people. They said, "Oh, hey, we're reading your article," and they come up and talk to us at a conference, and then they end up working in the team. So that's really good. But it's also useful from the perspective of working with external partners. Because they can see the kind of research that you're doing. It's all up online, and you can say, hey, well, we can give you similar insights for your project, so that's useful.
What about you? How do you find your talents?
So maybe just I will add the comment on open sourcing and sharing also researchers and so on. So in our case, it's more challenging because you can imagine that when we are working with external clients, you are working under NDA, and most likely when you are doing some audits, you are funding some stuff that client don't want to share with anyone, obviously. Or then even if you provided some interesting novel model and so on, like all of the IP is going to the client, and obviously client paid for that, and like unfortunately most of them don't want to open source it and share it. But I'm working on that, so we will be able to see recently that we started to share more and more of behind the scenes of our work, because when I'm playing this string of, hey, it will be also good for your marketing, like it's a win-win, then it started to work well. In terms of hiring talents, I think the obvious answer will be Token Engineering Academy, that's for sure. This is where, this is, if you are looking for, I have like plenty of years of experience in looking for people, because I was also building the software engineering teams from scratch, and I know the struggle of hiring. And especially like investing a lot of time with trying to understand that our people that are reaching out to you are like proper fit for your company and for the position, for the skills that you require. I don't have this problem with Token Engineering Academy, because I already know that there are people there that are interested in this field, which is already a lot for me, at least. I was always fan of a model that, hey, let's bring on board people with huge potential and huge interest to the field, and then we can like teach them the rest of the stuff. It's that easy. So we are actively using Token Engineering Academy. We are running our local study group, and we are using it in both ways. So one is looking for new talents, and the other one is onboarding new people, because when we are hiring somebody that is from different source, which we do have case, it was referral from our employee, then he is joining our Token Engineering study group to onboard himself on crypto world more, because the background is mathematics, statistics, and so on. So yeah, that's just kind of when it comes to filling this gap of the crypto knowledge. So that's for now, that's my main source. I'm not looking for anything else because it's enough for me.
Someone told me that the token engineering crowd is the least crypto enthusiastic crowd in crypto. I wonder, well, how important is it? Do you source people or find people who are crypto natives, or how relevant is it that you have a good understanding of crypto smart contracts, blockchains?
Yeah, that's a good question. I never heard that phrase like that before. I think I mean, one issue with hiring people for token engineering, for crypto economics, mechanism design is so multifaceted. You can hire somebody that's an expert in cryptography, but that's not enough. You need somebody who knows how to build models and simulate rational agents. You need somebody who knows about policy. There's just like so many different strings to it. So, I mean, it kind of depends. I mean, what are you thinking whenever you say, the crypto economists or token engineers are less interested in like crypto native? Like, how are you thinking about that?
Yeah, the thing is probably that we need a lot of skills that are not crypto native, that are stemming from other engineering disciplines, computer science, game theory. And then we see at TA Academy that the potential of token economies gets them excited for the sake of this idea, not necessarily for being practically involved. Yeah. And that sometimes causes issues because you have to understand the technical environment you're designing for.
Yeah, that's very true. So, I mean, this is something we like come across whenever we're working with other core devs, for example, at Filecoin. Like different people understand the system different ways. Some people take a very like top-level approach, and they come to it with some like principles, like, hey, this is the behavior we want to see. This is our objective. How do we go about designing an incentive to get there? Other people will be much more into the nuts and the bolts of like the smart contracts and the actors, saying, okay, this piece of code, this line interacts with this. Like, how can I change it to, improve the outcome? So it's like two different ways of understanding it. I don't think either is right. I think they're like complementary, and really you need both. It's like very rare to get like a single person who can do absolutely everything. So yeah, it's like collaboration is the name of the game.
Makes sense.
One additional comment maybe, but just so people don't get this perception of you need to be like highly technical and so on, because actually what I do believe, and we've talked about it also earlier, is that the skill that we are looking for the most is communication. So how much you are able to translate this whole complexity that we are talking about to potential client or the receiver of your simulations report and so on. I had plenty of discussions with token engineers that they were like, yeah, I can do modeling, I can do simulations, that's not a problem. And when I was asking, okay, can you do the simulation report and present it to the customer? No, I don't want to. So, and this is like huge issue. And when there are people that have, let's say, they're kind of T-shaped people where they have this good enough understanding of what we do here, basically, where is the value for the receiver of this information and how we are doing that, and have this strong ability to translate it to, let's say, human language at the proper level, this is a super skill. Okay.
Final question. Now, if anyone in the audience, a crypto project, thinks about, okay, we need to hire a crypto econ lab, we need to hire Tokenomia Pro, what should they have prepared to talk to you?
Not much really, because at the end of the day, this is the goal of the discovery phase that I mentioned. So clients reaching out to us with different requests at different stages. So you can either have only just high-level idea, that's enough. We will just probably have more time into the discovery phase to figure out what we can do. You can also be at the stage where even everything is live, and right now we are trying to figure out, okay, what's next, which is also where we are helping. So just reach out and we will discuss together what we can do.
Do you have any framework, checklist?
So I mean, we have a framework and a checklist for onboarding external clients. I mean, I would say the most important thing is just to be able to clearly articulate what is your idea of utility and what it is you're trying to maximize with the project. And from that, we can take it from there and help you design the crypto economic incentives that can achieve this.
Okay, thanks. We have some more time for questions, in case you guys have any.
This might be a funny question. Out of all the tokens out there, which one is the favorite design that you've seen so far?
I mean, naturally, I'm going to say Filecoin. I think it's a very good design. I think there's a lot of complexity and sophistication and things to keep us working on and to improve. And it is really a protocol that has to keep evolving because of what the utility is. It's growing storage, and in many ways, this is like a decentralized version of a storage company, so it's like a complex thing to work on and design the incentives for. But I think it's been good, very good so far, and I think there's more work to keep evolving that. I mean, what's your perception of your favorite token engineering project, Lukasz?
I mean, that's a question about what's the best, let's say, designed token and so on. It's a question without the answer, because it depends what was the ultimate function of this token, which I think the good example of that was today in the presentation about the Uniswap, like what's their main formula for what they want to optimize for. So first, we will need to know what each specific project we're optimizing for, and then this will, for us, lay the foundation of our, let's say, evaluation model of, okay, this is a good design, because, like, of course, by default, everyone is looking at token prices, right? And this probably, in most of the cases, will be not the best idea how to evaluate the project, because the token price was not the most important thing. Of course, it has impact, but maybe not at this stage is so important. The second one, like, the multiple ways of how the projects, market makers, whoever on the market are able to manipulate the price, it's endless, basically. But so then it's not really also a good metric to objectively evaluate, like, yes, this is a good token design. I have my couple of favorites, but not financial advice. And I will share it maybe later, because, yeah, it's live streamed.
I'd also like to point you guys to the first talk today where Trent talked about the evolution of Ocean. And I recommend to watch this video again, because to me it reflects very nicely that there is no final token design, and that you have to adapt your design to the evolution of your total protocol of your project. And sometimes you might run into problems or into a dead end. And then you have to be really brave to leave your... I mean, he talked about throwing away 90% of their code. This is something, and you have to deal with it with a token that is already live, manage these changes and manage this evolution. And I think it's a really great example to get into this thinking of it's an ongoing, progressing thing, and there is nothing like a finite, perfect design. You're interacting with the markets around you. Tokens are composable, so we have some really cool challenges to solve. Yeah, take a look at this presentation.
I will use this analogy of the tools that we are discussing. Like, okay, so what is the best tool for modeling tokens? I mean, it depends, right? Like, what does it mean the best? Is it the best in terms of performance? Is it the best in terms of how it's easy to use? Is it the best for because of, I don't know, it's the cheapest one? So I think the question itself will need to be, let's say, more specified, on top of which we are evaluating the design model. But it's a good question and trigger for the really good discussions. Thank you.
Any other questions? Final one. How to establish token engineering at your project? Shoot it. Yeah.
I don't mean to monopolize this, I apologize, but a quick question. You mentioned that you need to have a continuous design iterations for your tokenomics. How do you achieve that while ensuring decentralization and governance?
Yeah, sure. So, I mean, you're heavily reliant on the governance process. There's always complex trade-offs. So there's trade-offs in any ecosystem where some people may perceive that they're winners or losers from a given change.